So now in this video, I thought we would look at the forward voltage of LEDs and how they can stack up. So that's something to keep in mind when you are setting the current going through the circuit. When you got components in series, they're all connected end to end, including the power supply right there. There's one end, there's the other. Then you have the same amount of current flowing through everything right there. And if you have 9 volts across 1,000 ohms, then you can expect about 9 milliamps, 0.009 amps of current to flow through. Won't be exactly 9 milliamps probably, but pretty close. So we got 12 volts. The green LED is going to drop about 3 volts, leaving about 9 volts across the 1,000 ohm resistor. So now here you can see we got 12 volts power in that circuit, a little bit shy of 9 milliamps probably of current going through it right there, but really close to 9. Again, these won't be exact numbers. I already have the meter set to measure voltage. I don't need to move the red probe for anything but high current. But in any case, we can check the total voltage across this load right here. So it's showing a spec below 12. We do have like some resistance along the way and stuff, so that's going to lower it a little bit. That's to be expected. And there you can see, so it's not exactly 3 volts that the green LED is dropping, but it's pretty close right there to 3 volts. And then we got 12 volts at the supply, about 3 volts dropped, leaves us about 9 volts across the resistor, which is ultimately setting the current in this circuit. So now I have 2 of these green LEDs in series. I will turn the power off right now so there's no current, but there you can see anode, long lead, cathode, short lead. Same with this one there, anode there, short lead, cathode there. They are in series, one path, just like you see there. Now, I did the math differently here. If we have 6 volts, that's going to be across the resistor, and we want 9 milliamps of current, we're going to need about a 667 ohm resistor. I'm using a 680 ohm resistor because that is what's in my kit. But there you can see I expect 6 volts across it because each one of these LEDs is going to drop about 3 volts from the resistor. So it drops 6 volts from the power supply going across the resistor. Hopefully that makes sense. But again, we got about the same current there. And now we will take those voltage measurements. So first we got the supply voltage. Now each one of these LEDs, I'm going to go where they connect together, drops about 3 volts. I can measure this one independently right there. But we go across the 2 of them, now we got about 6 volts total, approximately. And again, 12 volts from the supply minus 6 volts will give us about 6 volts approximately across the resistor. And finally, we have 3 series LEDs. Remember, long lead anode always has to be more positive, short lead cathode has to be more negative, or else there will be no current flow. It will block more than 12 volts. And there you can see, I did the math. For 9 milliamps of current, when there's 3 volts across a 330 ohm resistor, remember I switched resistors there, we're going to need about 333 ohms. So that's approximate right there. So each one of these green LEDs is going to drop about 3 volts each for a total of 9, leaving about 3 left over out of that 12. And the power is not on right now. There we go. Turn the power on, and it actually says 9 right now. It may be closer to 9 milliamps of current. But there you can see the LEDs are on, and these are the other resistors I used earlier. And of course, we will do those voltage measurements right here. So this is good practice if you don't measure much. We got 12 volts total right there. It's one way you problem solve. You know what voltage should be across components. So 3 volts across the lone one. And I can't see because these LEDs are bright. There we go. The middle one and the top one here. And so they may be slightly different there, but it's approximately 3 volts each for a total of about 9 volts approximately. And again, I'm going kind of blind because these green LEDs are bright. And there we go. We got that 3 volts, slightly more, across the 330 ohm resistor. And that seemed, I believe, higher than the voltage that we expected across the other resistors earlier on. So I think that's why this power supply actually broke the 9 right there. It actually senses that it's delivering 9 milliamps of current instead of just slightly less. That's what I believe. But in case, make sure you turn the multimeter off when you're done. So again, these are basic components, resistors, LEDs, and you know, you need them multimeter sooner or later if you're into electronics. And so this is a good little test you can do. And you measure voltages across components all the time. That's a major part of electronics. Helps you understand what's going on in the circuit. So I believe this is a good practice circuit to do even once you got the basics of the adding up voltage drops and stuff like that. Gets you more familiar with the circuit. So in any case, thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help a lot. I'll see you in the next video.